We now define the semantics for program graphs as generated from guided commands. The semantics consists of a non-empty set called the memory, and a semantic function that for each action specifies how the memory is transformed. For guided commands, the memory is a mapping from variables to integers, and there are three kinds of actions to look at: assignment, skip, and pass if Boolean condition is true. The semantic function says that for skip, the start memory sigma is also the end memory. For assignment, it says that the end memory is a start memory modified such that x maps to the value of the arithmetic expression a in the starting memory sigma. If x is not known or the arithmetic expression is undefined, then the overall effect is undefined. For parse a Boolean expression, it says that the end memory is the same as the start memory if the condition is true. Otherwise, it is undefined. For a complete explanation, we also need to detail how to evaluate an arithmetic expression and a Boolean condition. We return to this shortly. Now it is time to reconsider the online systems at formermethods.tk. Once we have chosen the stepwise execution environment, we can indicate the values of variables in the initial memory, and the system will construct an execution sequence. It will show the actual actions being performed, and it will highlight the places in the memory where changes have taken place. Now we extend guided commands with arrays. An example program is shown here. It sums all the entries in an array, assuming it has length 10. The BNF for the syntax is extended as follows. There is a new command being an assignment to an array entry, and there is a new arithmetic expression being a lookup of an array entry. The construction of program graphs follows the method already used for assignment to variables. The memory is also changed to not only map variables to integers, but also to map array entries to integers, but only for those entries of an array that are within bounds. The semantic function for array assignment first evaluates the indexed and next the new value. Then it produces an end memory where the array entry has been updated. It is undefined if A1 or A2 turns out to be undefined or the index is out of range. We now have to consider the evaluation of arithmetic expressions. So let us consider the memory as indicated here. X is 12, I is 2, and the array A has 4 entries with values 2, 3, 7, and 5. We need a definition of a semantic function for arithmetic expressions such that we could do a calculation like the one shown here. It works out the value of x plus a of I in the memory shown, and we get the value 19. The definition is shown here. There is one equation for each form of arithmetic expression. A number just gives a number. For a variable, we make a lookup in the memory. For an array entry, we first compute the value of the index, and then make a lookup in the memory. The result is undefined if the value is undefined or the index is out of bounds. For other operators, we evaluate the two arguments and apply the operator. The operators are shown here. Most are straightforward, but one needs to consider the precise details of integer division in the case of negative numbers. Similarly for exponentiation. For Boolean conditions, we have one equation for each form of Boolean expression. The overall approach is very much like for the arithmetic expressions. The relational operators and the Boolean operators are shown here. Special attention needs to be given to the difference between ordinary conjunction and short-circuit conjunction. The example here shows a case where ordinary conjunction is undefined, but short-circuit conjunction is defined. The explanation in the book pays more attention to this than this slide. Now it is the time for you to use the tool at formermethods.tk. Try to use the power function and see what happens if some of the numbers are negative. Do a simple experiment with insertion sort What happens if the size of the array is different from n? What happens if you use ordinary conjunction instead of short circuit conjunction? What happens if comparison operators are changed from strict to non-strict? Once you've done this, you should read the section in the book, doing the try-it outs on the way.